All right, let's learn about inverse trig functions. So you might recall a normal function. The normal sine function looks something like this, right? Where the domain is all real numbers and the range is from -1 to 1. But if I were to look at the inverse of the sine function, notice how it only goes from -1 to 1, and all the possible y values are from -pi/2 to pi/2. So what's happening? And I just wrote the domain and the range for all of the other inverse trig functions. Well, what's happening is that we gotta go back to basics. Remember that, for a function to kind of work, you're gonna have one x value, you have one input, and that leads to one output. All right. But the problem is that for inverse trig functions, if we didn't restrict the range of this function, so if the range of this function was not from pi/2 to pi/2, and it was, for example, all real numbers, well, then things wouldn't work out. Now, from the unit circle, you might recall that this is going to be equal to square root of 2 over 2. However, one property of inverse functions that you might remember is that if you have f of x, that's going to lead to a y value. If you take the inverse of that y value, you get back the original x. In other words, f inverse of f of x gives you back your original x value, right? But that is not the case for the trig functions. In this case, if I took the inverse sine on both sides, I'm going to get that sine inverse of the square root of 2 over 2 is going to be equal to 3 pi over 4. Now remember that, in order for a function to work, you have one input and that leads to one output. When we have sine of an angle, right? If you have sine of an angle, that's only going to lead to one value. And for inverse functions, remember that this is kind of the reverse, right? If you're given a value, you have to find the angle that corresponds to that value, right? So on the unit circle, right, to visualize this, right, for original trig function, you're given the angle, and you have to find out the value, right, that it corresponds to. In this case, sine represents the y value of a certain angle. So if I have an angle like so, theta, it's going to correspond to this only one y value, right? It only corresponds to one y value. However, multiple y values can correspond, a y value can correspond to multiple angles. So if I do the reverse, let's say if I'm given that my sine value is a certain point, well, notice how there's other angles that correspond to the same value. So in this case, I can't say that the inverse sine of the square root of 2 over 2 is equal to 3 pi over 4. Because from that logic, then pi over 4 also works. And let's say if I keep adding 2 pi to this, then it's just going to be 9 pi over 4. And then this just kind of keeps going, right? You have kind of like an infinite amount of answers, right? Because what this problem is basically saying, and you might remember this from solving trig equations, but if you're given that your sine value is the square root of 2 over 2, so let's say if you're given that this y value is the square root of 2 over 2, and you're trying to find the angle that corresponds to it, well, notice how you can just keep going 2 pi around the circle, right? You have one answer here, right? You have one answer here where you have this angle that corresponds to the square root of 2 over 2. But notice how for both of these angles, you can keep going around the unit circle by adding 2 pi, or 360 degrees, right? You keep going 360 degrees around the unit circle, and you'll still end up with the same y value, right? Because it's a full 360 rotation, right? You end up at the same place you were before. So this is why for inverse sine, you restrict the range of the function to be -pi/2 to pi/2. And what that looks like on the unit circle is you're basically shutting down half the unit circle, right? Actually, more than half, because you're restricting all other plus 2 pi n's. But imagine that you're restricting the unit circle from pi/2, from the angle pi/2, right? So this has an angle of pi/2, right? So you're restricting this unit circle from the angle from pi/2 to -pi/2, right? So from -pi/2 like this, right? And now that I've restricted my unit circle, now for every sort of y value that I have, it only corresponds to one angle, right? So I restricted my inverse sine range from pi over 2 to negative pi over 2, right? So that means that whatever sort of value that I have, the angle that corresponds to it has to be between pi over 2 and negative pi over 2. And I should have put this, but you know, your inverse sine of the square root of 2 over 2 is just going to be equal to pi over 4, because that is the angle that falls inside of the range for this function, right? The range is from negative pi over 2 to pi over 2. All the other angles are not in this range, right? But pi over 4 is. So that is going to be our answer. All right. So yeah. So make sure that, when you're doing this inverse kind of trig problems, you're going to pick the answer that is inside the range of this function. Now, you also have to remember that the domain is also restricted. So in addition to the range being restricted, the domain is also restricted. So if I were to, let's say, if I wanted to find out the sine inverse of 2, what that is equal to, well, this is going to be undefined. There is going to be no real answer. And the reason for that is because in the context of an inverse trig function, remember that you have sine of some angle it corresponds to one value, right? However, this is giving you a value, right? If we're given that the value is equal to 2, find the angle that corresponds to it, right? So if we're given that sine of some angle is equal to 2, well, what is the angle that corresponds to it? But notice how for sine of x, notice how for sine of x, all values are in between -1 and +1. There is no there is no kind of sine angle that corresponds to a value of 2. So that is why this does not work. Now, what is this going to be equal to? Well, restate the problem in like simpler terms. So if we are given on our unit circle that whatever y value we have is equal to 1/2. So whatever y value that we have is equal to 1/2. Find the angle that corresponds to it. Find the angle that corresponds to it. Notice how I'm drawing my angle here notice how I'm drawing the angle from negative pi over 2 to pi over 2, right? So this is negative sort of pi over 2, this is pi over 2, right? Remember that my angle cannot be here in quadrants 2 or 3 because, well, we're restricting our range to this, right? All our possible answer choices are in between quadrant 1 and quadrant 4, right? So that's why I drew the angle in quadrant 1, right? Because this is our restriction. So what angle corresponds to this? Well, looking back on your unit circle, you might have remembered that an angle of 30 degrees or pi over 6 corresponds to a y value of 1/2, all right? So whenever you're doing these inverse sine problems, you have to ask yourself, all right, first of all, does this value even work in the first place? Is it inside the domain for the inverse trig function? Second step is to draw out the unit circle, and you have to memorize the range restrictions as well. So not only do you have to memorize the domain, but you have to memorize the range restrictions. And remember that the range restrictions, in this case, it's from negative pi over 2 to pi over 2, which means that whatever answer I have has to be in between these two values, right?